The Roman Empire left behind roads, aqueducts, towering amphitheaters, and engineering achievements that still amaze the modern world. Archaeologists have uncovered millions of Roman artifacts over the last 2 centuries, and most of them eventually revealed their purpose. Swords were made for battle. Coins carried the faces of emperors. Oil lamps lit homes after sunset. Even the smallest household tools could usually be identified with enough research. But one object continues to defy every explanation. It is no larger than a baseball, made almost entirely of bronze, shaped like a 12-sided geometric figure, with perfectly circular holes cut into each face and small knobs decorating every corner. More than 100 of these mysterious objects have been discovered across Europe, yet not a single Roman document explains what they were for. No surviving inscription mentions them. No ancient drawing clearly shows someone using one. For nearly 300 years, this strange artifact has remained one of archaeology's greatest unsolved mysteries. Recently, the mystery attracted attention once again after artificial intelligence systems, including Grok AI, were used by researchers and enthusiasts to examine the available archaeological evidence from a fresh perspective. Rather than relying on traditional assumptions, AI was asked to compare measurements, locations, manufacturing techniques, and historical records simultaneously. The result was not a final answer, but something far more intriguing. Several long-standing theories became weaker, while entirely new patterns began to emerge. Instead of simplifying the mystery, the digital analysis suggested that the Roman Dodecahedron may have been far more sophisticated than historians originally imagined. The conclusions sparked intense debate across archaeology communities, with some experts welcoming the new insights, while others urged caution against drawing conclusions from incomplete evidence. The story actually begins long before computers ever existed. In 1739, workers digging in England uncovered an unusual bronze object, unlike anything they had seen before. At first glance, it resembled an elaborate ornament, but its perfectly symmetrical construction suggested otherwise. It possessed 12 pentagonal faces, each containing a circular hole of different diameter. 20 rounded knobs decorated its corners with remarkable precision. The object showed clear signs of expert craftsmanship, yet no one could identify its purpose. Over time, additional discoveries appeared in France, Germany, Belgium, Switzerland, Austria, Hungary, Luxembourg, and the Netherlands. Each new excavation added another piece to the puzzle, but none provided the missing explanation. Today, archaeologists know of well over 100 Roman dodecahedrons. Most date to the 2nd through 4th centuries AD, during the height of the Roman Empire. Surprisingly, none have been discovered in Italy, Greece, North Africa, or the eastern provinces where many other Roman artifacts are common. Instead, nearly every example comes from the empire's northern frontier, particularly regions corresponding to modern-day France, Belgium, Germany, and Britain. That unusual distribution immediately raised questions. If the object served an essential purpose throughout the Roman world, why did it appear only in certain provinces? Even more puzzling is the remarkable consistency among the artifacts. Although their sizes vary slightly, most measure between 4 and 11 centimeters in diameter. Each possesses 12 pentagonal faces. Each has 20 rounded knobs. Each contains holes of different sizes arranged in similar positions. Roman metalworkers clearly followed recognizable design principles. These were not random artistic experiments. They were manufactured according to a pattern that craftsmen understood. Creating such an object was no simple task. Roman bronze casting required exceptional skill. Craftsmen first sculpted detailed wax models before surrounding them with clay molds. After heating the mold, the wax melted away, leaving an empty cavity that molten bronze could fill. Once cooled, the clay was broken apart, revealing the finished casting. Every hole then required careful finishing, and every surface needed polishing. Producing even one dodecahedron demanded considerable time, experience, and expensive materials. This immediately challenged one popular theory, that the objects were simply children's toys. The Romans certainly made toys, but they rarely invested this level of craftsmanship into ordinary playthings. As more examples were examined, another mystery appeared. No two dodecahedrons are exactly identical. The hole diameters differ. The spacing varies slightly. Some are beautifully decorated, while others appear relatively plain. Yet the overall design remains unmistakably consistent. That combination suggests local workshops were following a shared concept rather than mass-producing identical instruments. For decades, scholars proposed one explanation after another. Some believed the dodecahedrons were candle holders because a few examples contained traces of wax. Others argued the wax likely entered centuries later after burial or museum storage. Another theory suggested they served as decorative mace heads mounted on wooden handles. However, the delicate bronze construction would likely have shattered under repeated impact, making them impractical as weapons. Other researchers proposed they functioned as astronomical instruments. The varying hole sizes might allow users to observe stars or measure the sun's position during different seasons. While mathematically possible in certain situations, no surviving Roman text describes such a device. Ancient Roman writers documented military equipment, surveying tools, religious ceremonies, and engineering techniques in remarkable detail. Yet nowhere do they clearly mention bronze dodecahedrons. Religious explanations soon followed. Several dodecahedrons were discovered near temples or ritual sites, leading some historians to believe they held ceremonial significance. Ancient religions often employed mysterious objects whose meanings were known only to priests or initiates. If the dodecahedron belonged to secret rituals, its absence from ordinary historical records would become easier to understand. Yet this theory also faces problems. Many examples were recovered from ordinary settlements, farms, military camps, and civilian homes rather than exclusively from sacred locations. One of the most widely discussed modern theories suggests the objects were knitting tools used to create gloves. Experimental archaeologists demonstrated that yarn can indeed be wrapped around the various holes to produce knitted fingers of different sizes. Because Roman soldiers stationed along the cold northern frontier needed warm clothing, this explanation gained considerable attention. Yet critics remain unconvinced. No Roman artwork depicts such a technique, and no written instructions survive despite the Romans documenting many aspects of textile production. The deeper researchers looked, the stranger the mystery became. Every explanation seemed plausible at first, only to collapse under closer examination. Each theory answered one question while creating several new ones. If the objects were measuring devices, why are there no instruction manuals? If they were religious symbols, why do they appear in everyday settlements? If they were tools, why do their dimensions vary so dramatically? This is precisely why artificial intelligence has generated so much interest. Unlike human researchers, AI does not begin with a favorite theory. It examines measurements, historical records, excavation reports, metallurgy, geometry, manufacturing methods, and artifact locations simultaneously, searching for hidden relationships that people may overlook. Rather than asking, "What does this look like?" AI asks, which measurable patterns repeat across every known example. That shift in perspective may prove to be one of the most important developments in the history of the Roman dodecahedron. After centuries of speculation, researchers are no longer relying solely on educated guesses. They are beginning to let the data speak for itself. And according to the newest analyses, the patterns hidden inside these mysterious bronze objects may point toward a story far more remarkable than anyone expected. AS researchers continued collecting Roman dodecahedrons from archaeological excavations across Europe. They noticed something that changed the direction of the investigation entirely. The mystery wasn't only about what the objects were, it was also about where they were found. Nearly every authentic Roman dodecahedron had been discovered in provinces that once bordered the northern frontier of the Roman Empire. Britain, Gaul, Germania, Belgium, Luxembourg, and parts of Switzerland produced almost every known example. Yet in Italy, the heart of the empire, where millions of Roman artifacts have been unearthed, not a single confirmed Roman dodecahedron has been recovered. That geographical pattern immediately suggested these strange objects served a purpose connected to life on the empire's frontier rather than everyday Roman society. Roman frontier provinces were unlike the peaceful cities surrounding Rome itself. These regions faced constant military activity, difficult weather, unfamiliar terrain, and interaction with neighboring tribes. Soldiers, engineers, surveyors, merchants, and local craftsmen all lived together in settlements that blended Roman technology with regional traditions. If the dodecahedron originated there, perhaps it solved a problem unique to those distant provinces. Excavation reports revealed another fascinating clue. The dodecahedrons rarely appeared alongside ordinary household objects. Instead, many were discovered near military settlements, wealthy villas, workshops, or areas associated with skilled craftsmanship. Some had been carefully buried with valuable possessions. Others appeared inside storage pits or building foundations. A few were recovered from graves, although not in large enough numbers to suggest they were standard burial objects. This inconsistent context only deepened the mystery. Researchers also examined the bronze itself. Metallurgical analysis showed that most dodecahedrons were cast from high-quality copper alloys similar to those used for expensive Roman equipment. This was not cheap metal. Bronze required significant resources, and Roman foundries carefully controlled its production. If someone commissioned dozens of these intricate objects across several provinces, they must have believed the effort was worthwhile. Under powerful microscopes, scientists studied tiny scratches left behind by centuries of handling. Surprisingly, the wear patterns were inconsistent. Some dodecahedrons showed heavy smoothing around particular holes, while others displayed almost no wear at all. Several examples contained slight polishing near specific knobs, suggesting repeated contact with human hands. Yet none displayed the kind of severe abrasion expected from heavy industrial use. Whatever these objects were designed to do, they were handled carefully rather than subjected to constant rough labor. One especially interesting discovery came from comparing the holes themselves. Every face contains a circular opening, but almost none of the holes share identical diameters. Some are only a few millimeters wide, while others approach several centimeters. Even more curious, opposite holes often appear deliberately paired. Certain combinations create precise viewing angles when someone looks through both openings simultaneously. That observation gave rise to one of the most discussed theories in recent decades. Could the Roman dodecahedron have functioned as an optical instrument? Military historians quickly became interested. Roman armies depended on accurate distance estimation during warfare. Archers, engineers, and artillery crews needed reliable methods for judging range. If a soldier knew the approximate height of an object in the distance, perhaps an enemy standard or fortress wall, looking through carefully matched holes might allow him to estimate how far away it stood. Experimental archaeologists constructed replica dodecahedrons using the dimensions of authentic artifacts. During field tests, some replicas produced surprisingly consistent distance estimates when paired with objects of known height. The results were encouraging enough that several researchers argued the dodecahedron could have served as an early range-finding device. However, problems soon appeared. No two authentic dodecahedrons are identical. Hole sizes differ significantly from one artifact to another. If these were standardized military instruments, Roman engineers would almost certainly have produced them according to uniform specifications. Roman military equipment was famous for consistency. Helmets, shields, swords, armor, and surveying tools followed strict patterns throughout the empire. The dodecahedrons did not. Other scholars proposed a different explanation. Perhaps they were not military instruments issued by the Roman government. Instead, individual craftsmen or surveyors may have customized them for personal use. Just as modern measuring tools can be calibrated differently depending on their task, perhaps each dodecahedron served its owner's specific needs. Artificial intelligence entered the debate by approaching the evidence differently. Rather than beginning with assumptions about warfare or religion, AI systems compared thousands of individual measurements simultaneously. They analyzed hole diameters, face angles, knob placement, bronze composition, artifact weight, discovery locations, manufacturing precision, and were patterns all at once. Unexpected relationships began appearing. Several dodecahedrons shared proportional ratios despite having completely different overall sizes. In other words, although one object might be much larger than another, the relationship between certain hole diameters remained remarkably similar. Engineers recognized this immediately. Such proportional scaling often appears in instruments designed according to mathematical principles rather than artistic decoration. The geometry itself became increasingly impressive. Every pentagonal face connects to 5 neighboring faces with extraordinary precision. Modern computer modeling demonstrated that small manufacturing mistakes would quickly destroy the object's symmetry. Roman craftsmen clearly possessed both the mathematical knowledge and technical skill necessary to produce these complex shapes consistently. Another surprising discovery involved the famous knobs decorating each corner. For years, many researchers assumed they existed purely for decoration. Yet digital simulations suggested another possibility. The knobs prevent the object from resting flat on any face, reducing wear around the holes while allowing air and light to pass beneath the artifact. If the holes serve some observational purpose, protecting them from obstruction would make practical sense. Some experimental researchers inserted wooden rods through opposite holes and found that certain combinations created stable geometric frameworks. Others stretched cords between multiple openings, producing symmetrical patterns useful for alignment experiments. Although none of these tests proved the original function, they demonstrated that the object's design allowed far more versatility than previously imagined. Perhaps the greatest challenge came from something AI could not find. Despite comparing the Roman dodecahedron against thousands of known historical artifacts, from surveying equipment and astronomical instruments to religious objects, locks, mechanical devices, weaving tools, and engineering components, no exact parallel emerged. The algorithms repeatedly concluded that the dodecahedron occupies an almost unique category within the archaeological record. That result may sound disappointing, but to historians it was profoundly important. It suggested the object was probably not a misunderstood version of some familiar Roman tool. Instead, it may represent a specialized invention whose purpose disappeared completely after the collapse of Roman authority in Northern Europe. If the knowledge required to use it vanished alongside the communities that create it, the silence in historical records suddenly becomes much easier to understand. For nearly 17 centuries, these remarkable bronze objects have challenged every generation that has examined them. Modern technology has answered many questions about their construction, their craftsmanship, and their distribution. But the single most important question remains unanswered. What exactly were the Romans looking at or measuring through those mysterious holes? If there is one theory that refuses to disappear, it is the idea that the Roman dodecahedron was connected to astronomy. For centuries, civilizations across the ancient world watched the skies with extraordinary precision. The Romans inherited astronomical knowledge from the Greeks, who themselves had built upon discoveries from Egypt, Babylon, and earlier cultures. They tracked the movement of the sun to organize agriculture, observed the stars for navigation, and used celestial events to establish important religious festivals. Knowing this, some researchers began asking an obvious question. Could the mysterious bronze dodecahedron have been another forgotten astronomical instrument? At first, the idea seemed unlikely. The object has no engraved markings, no numbers, and no moving parts like later scientific instruments. But when engineers created highly accurate 3D scans and examined every angle, something unexpected appeared. The holes were not positioned randomly. Looking through one hole toward the opposite opening created a narrow cone of vision. Because every pair of holes had different diameters, each combination produced a different viewing angle. Suddenly, researchers realized that the dodecahedron could function almost like an adjustable sighting device. Using computer simulations, investigators recreated how sunlight would pass through the various openings during different seasons. Certain alignments produced remarkably precise beams of light. At specific times of the year, sunlight entering one hole could pass cleanly through the opposite opening and illuminate a very small target beyond. Some researchers wondered whether this feature could have helped determine seasonal changes, particularly the arrival of spring planting or the beginning of winter. The agricultural calendar was extremely important throughout the Roman Empire. Farmers depended on accurate seasonal timing to maximize harvests. Although official calendars existed, local weather conditions often varied across distant provinces. An observational tool capable of confirming the sun's position could have been valuable, especially in frontier regions where Roman settlements blended with local traditions. To test this theory, archaeologists built full-size replicas based on actual discoveries. During field experiments, they observed the sun over many months. Some results appeared promising. Certain hole combinations lined up closely with the sun's altitude during equinoxes or solstices. However, just as excitement began to grow, another problem emerged. Not every dodecahedron behaved the same way. Because each artifact possesses slightly different dimensions, no universal astronomical pattern could be demonstrated. One dodecahedron might align with a particular solar angle, while another produced noticeably different results. Critics argued that if the Romans intended these objects as scientific instruments, they would almost certainly have standardized the measurements. Supporters responded with an interesting counter-argument. What if each dodecahedron had been made for a specific latitude? The Roman Empire stretched from North Africa to northern Britain. The sun appears at different angles, depending on where an observer stands. Perhaps craftsmen adjusted the instruments according to the region in which they would be used. Artificial intelligence tested that possibility by comparing the dimensions of surviving dodecahedrons with the locations where they had been discovered. At first glance, a few weak correlations appeared. Objects from certain regions shared similar proportions. But once additional examples entered the database, those patterns became inconsistent. The evidence simply wasn't strong enough to support a regional calibration system. Still, AI uncovered something else that surprised researchers. Many of the artifacts displayed an unusual balance between symmetry and variation. The overall geometry remained extraordinarily consistent, while the hole diameters varied in controlled ways. Engineers described this as design flexibility. Instead of manufacturing identical instruments, Roman craftsmen may have intentionally produced slightly different versions suited to different purposes. That idea led to another possibility. Perhaps the dodecahedron wasn't designed for a single task at all. Modern multi-purpose tools combine several functions into one compact device. A Swiss Army knife, for example, contains blades, scissors, screwdrivers, and files within a single object. Could the Roman dodecahedron represent something similar? Depending on which holes were selected, users might perform different measurements, observations, or calculations. Experimental archaeologists eagerly explored this concept. Some used the holes to measure rope thickness. Others tested whether the openings could determine the diameter of wooden poles. Several engineers experimented with surveying techniques by aligning distant landmarks through opposite holes. None of these experiments produced definitive proof, yet many demonstrated that the dodecahedron could perform surprisingly accurate geometric measurements when used creatively. The object's craftsmanship also continued to impress experts. Bronze casting during the Roman period was already an advanced technology, but producing a perfectly symmetrical hollow dodecahedron required exceptional precision. Every face had to align correctly before the molten metal cooled. Even slight errors could distort the entire structure. The surviving examples reveal that Roman craftsmen repeatedly achieved this difficult feat without modern machinery. Microscopic analysis of casting marks revealed another fascinating detail. Many dodecahedrons appear to have been finished by highly skilled artisans rather than ordinary foundry workers. Fine filing marks, careful polishing, and precise edge corrections suggest these objects were valuable enough to justify extensive hand finishing after casting. If they were expensive, that raises another important question. Who actually owned them? Ordinary Roman citizens probably could not afford intricate bronze instruments requiring days of skilled labor. Wealthy landowners, military officers, engineers, surveyors, priests, or specialized craftsmen become much more likely candidates. Unfortunately, the archaeological evidence refuses to provide a clear answer. Some dodecahedrons were discovered in affluent Roman villas. Others emerged from military settlements. A few appeared in small rural communities far from major cities. No single social class can be confidently linked to the objects. Artificial intelligence examined another overlooked feature, the decorative knobs. For decades, historians assumed they served no practical purpose beyond aesthetics. But digital structural analysis demonstrated something unexpected. The knobs significantly strengthened the corners where multiple faces joined together. Without them, repeated impacts could create stress fractures in the bronze. The rounded projections distributed mechanical force more evenly throughout the object, increasing its durability. In other words, the knobs were not simply decorative. They were functional engineering. That realization changed how many researchers viewed the entire artifact. If Roman craftsmen intentionally strengthened the structure, they expected these objects to be handled regularly rather than displayed as ceremonial decorations. Even after all these discoveries, one uncomfortable fact remained. No ancient Roman writer, not Pliny the Elder, Vitruvius, Frontinus, or any other surviving author, ever described such an object. Roman civilization recorded military campaigns, engineering projects, architecture, medicine, agriculture, law, and religion in extraordinary detail. Thousands of texts survived the centuries. Yet on the subject of the bronze dodecahedron, silence. Some historians believe this silence may hold the greatest clue of all. Perhaps the knowledge surrounding these mysterious objects was never widespread. Perhaps only a small community of specialists understood their purpose. When Roman authority collapsed across northern Europe during the 5th century, those specialists disappeared. Workshops closed. Traditions ended. Practical knowledge passed from master to apprentice simply vanished. If that happened, the dodecahedron may represent something incredibly rare in archaeology, a sophisticated technology whose purpose was forgotten not because it was hidden, but because every person who understood it disappeared from history. As more Roman dodecahedrons surfaced across Europe, researchers realized they were dealing with something far stranger than a single mysterious artifact. Every new discovery added another layer to the puzzle. Some examples were found buried alongside valuable coins, jewelry, and luxury household items, suggesting they belonged to wealthy individuals. Others emerged from abandoned military settlements along the Roman frontier, while several appeared near religious sites where rituals had once been performed. The variety of locations made one thing clear: there was no obvious pattern linking them all together. This diversity created a major problem for archaeologists. If the dodecahedron had served only one purpose, it should have appeared in similar environments throughout the Roman world. Instead, each discovery seemed to tell a different story. Some objects looked almost brand new despite